right, we're back with section 2.1. So in this video, we are going to be organizing qualitative data in tables, creating bar graphs, and creating pie charts. As with our last video, there is an accompanying PowerPoint. You don't necessarily have to watch this whole video unless you want the instruction with it. Unless the PowerPoint doesn't give you enough, then feel free to watch this video, or you can just send me emails, ask me questions. I'm happy to answer them. So first, as a reminder, qualitative or categorical data provides measures that categorize or classify an individual. Remember, these are things that are non-numerical, or if they are numerical, it's not numbers we're going to do math with. So it would be things like a zip code, or maybe, I don't know, like your address, something like that, something, phone number. Those would be categorical things because it may be numbers, but you're not going to be doing math with it. So a frequency distribution, this is a new word. It lists each category of data and the number of occurrences for the category of data. So I'm going to show you what that looks like in just a second. So first though, the data that you collect from a survey, so the data when we don't organize it, before we organize it or list it or any of that, just the data that you collect, so your big list or your big pile of data is just the raw data. Before we do anything with it, your big list of answers. So if you asked all of your friends, are you left-handed or right-handed, and you just have listed down left, right, left, right, left, right, you hadn't done anything else, that would just be your raw data. So here's ways that we can organize our data with tables, graphs, numerical summaries. There are other ways, but this is what we're going to look at right now. So first, the next slide that we have is going to represent M&Ms in a bag of plain M&Ms. So we just have just a big bunch of the raw data. So it looks like pretty much nothing, and we're going to create a frequency distribution of the color of plain M&Ms. So here's my raw data. So basically, as I'm pulling the M&Ms out of a bag of M&Ms, okay, brown, brown, yellow, red, 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 and on and on. So this is just the raw data. It is not organized in any way. It's just the way that they came out of the bag. So this is my frequency table. So as you can see, I have each color listed, and as I counted them out, I have tally marks. You do not necessarily need to show the tally marks if you're creating a frequency table. If you just had this row and this row, you're good. This tells me there were 12 brown, 10 yellow, 9 red, 6 orange, 3 blue, and 5 green. It just tells me how many times, how frequently did each one show up. That's all that is. So in order to determine the relative frequency, so the relative frequency is the proportion or percent of observations within a category. So basically you take the frequency and you divide it by the total. So if I added all of the number of M&Ms up and I've said just put the brown over the total number of M&Ms, it's going to tell me the percent of the M&Ms that were brown. So in order to create a relative frequency distribution, we are going to find that relative frequency of each of our M&M colors. So here, as you can see, when I add them all together, I had 45 M&Ms total in the bag. I did 12 divided by 45, and I got 0.2667, so approximately 27% of my bag was brown. And I did 10 divided by 45, and I got this for yellow. And 9 divided by 45, and I got this for red. So this is the relative frequency. This tells me the percent of M&Ms in the bag that were each of these colors. This should always add up to 1, or because 100% is our total. But sometimes it's a little bit off because of rounding, but it's always going to add up to right about 1. So that is a relative frequency table. So remember, the frequency is just how frequently does that color show up. The relative frequency says the percent of the time that one shows up. So a bar graph, I'm sure you've heard of bar graphs, you've seen bar graphs. Maybe you've never created a bar graph before, or maybe you have, who knows. But the rectangles are going to be equal width, I often will use graph paper if I'm drawing one so that it makes it a little bit easier to make them equal width. The height of the rectangle represents the category's frequency or relative frequency. So it really depends if we're doing a frequency bar graph or a relative frequency bar graph. I'm going to show you both for the M&Ms. So we're going to be constructing a relative frequency bar graph and a frequency bar graph. So here is my frequency table. We already had that. And I'm going to use these to tell me how tall each of the bars should be. So here we go right here. So you see I have brown and it goes up to 12. I'm counting by 2 on the frequency. The frequency is along the left side. It would be my y-axis if you're looking at a graph. And then my x-axis would be the color. And each of these bars is equal width. They are not touching each other. They're equal width and they go up as far as how often that color occurred. So as you can see, blue, it goes up halfway between the 2 and the 4, so there's 3 blues. The green goes halfway between the 4 and the 6, because there's 5 of them. You can see each of those represents how often that color showed up on our frequency table. So now let's look at our relative frequency table. We are going to be using the relative frequency now as our y-axis. So take a look here. So the relative frequency is along the side, is now my y-axis. Make sure when you create these bar graphs that you are labeling your x and y-axis and you are giving it a title. This is very important. You need to have a title. You need to label those x and y-axes. So once again, I have the colors along the bottom, and then instead of the frequency along the side, it is showing me the proportion of the bag that is that color. And you kind of have to estimate with how tall your bars are, so you just need to estimate. I'm not going to be a real stickler about it being perfect. I'm going to look at, is it close? And these are close, of course, because our textbook gave it to us, so of course it's close. So next, we're going to talk about a Pareto chart. So you're going to occasionally be asked about a Pareto chart. Pareto chart is just a regular bar graph, frequency or relative frequency, but instead the bars are in order, decreasing order of frequency or relative frequency. So let me show you what that looks like. So here I did, for some reason I lost the blue. The blue fell off the end. Who knows where it went, but I lost that. Let's pretend that that blue is on the end. So brown was the highest, yellow was the next. So as you see, it's like stair stepping down. So it goes from the highest relative frequency to the lowest relative frequency. That is the only difference between a regular bar graph and a Pareto bar graph, is that we list it in order of frequency. So now when we're comparing two data sets, it's going to look a little bit different. So here, the data represents the marital status in millions of U.S. residents 18 years of age and older in 1990 and 2006. So what we're doing is we are comparing the marital status of the residents in those 2 years. So as you look, 1990, for example, the never married, in 1990, 40.4% of people 18 and older had never married. In 2006, 55.3% had never married. And you can look down at each of these. The only one that is approximately the same would be widowed. But if you look down at these, and you can see the comparison. So we're going to show this on a side-by-side relative frequency bar graph. So first thing we're going to do is we're going to calculate the relative frequency. How do we do that? We take the total and you divide the number of never married by the total of all of them added together. So here, let me see here, I would add them all together. So let me see, 40.4 plus 1112.6 plus 13.8 plus 15.1. So it's 181.9, so I would take 40.4 divided by 181.9, and 112.6 divided by 181.9, and on and on. Then I would do the same thing with 2006. I would add all of these together. I would take this and divide it by that total. So for this here, it'd be 40.4 divided by 181.9. 112.6 divided by 181.9. You get the picture? That's what we're doing here. So you take a look here for our relative frequencies along the side. And here's my side-by-side bar graph. If you create a side-by-side, make sure you have a legend over here. This legend here tells us that the light blue is 1990 and the dark blue is 2006. Once again, my y-axis is relative frequency. Your y-axis will always be either frequency or relative frequency. My x-axis is the marital status. And make sure that you also have a title on your graph. Pie charts. So one thing about pie charts is I will never make you create one by hand. You will be creating one in Excel, and it's actually pretty cool and fun, and there's a lot of really great things that you can do with it and play with it. But I'm not going to make you do one by hand because it would require having a protractor. It would require probably having a compass, and it's not a whole lot of fun creating one by hand. But a pie chart is a circle divided into sectors. Each sector represents a category of data, and the area of the sector is proportional to the frequency of the category. So you would need the relative frequency on all of those. So let's take a look at marital status. This is just the 2006 data. So remember, we use this with the side-by-side. So let's take a look. So here you can see that each piece represents one of these, and the color coded. If you create one, make sure that you label everything well. So you would have to calculate the degrees and use a protractor to measure the angles. Don't worry, you don't have to do one by hand. I really like the way that pie charts look and the way that they show data. I think it's really nice and clean. It's pleasant to look at. I love them on Excel. So when you're doing your final project, which you don't know much of anything about, but I think if you plan a nice pie chart in there, I think it'd make your grader happy. So that is it for 2.1. If you have any questions, make sure you send me an email and I will do my best to answer them, or go to the forums and put a question in there. One of your classmates may have the answer. Thank you very much.